You know the feeling? You look up at the stars on a clear night, and it's almost impossible not to wonder, are we the only intelligent species in the universe? It's highly likely that if extraterrestrial civilizations exist out there, they're looking up at their own skies and asking the exact same thing.
But instead of just wondering, humanity actually decided to answer that call. Back in 1977, NASA made the incredibly bold decision to physically launch a message out of our solar system and into the cosmic void. This wasn't just some science experiment. It was a profound declaration of our existence, marking the start of an incredible narrative that is literally still unfolding today.
Section 1. A Message to the Stars.
The origins of this journey actually date back to 1965. A NASA engineer noticed that the four outer planets, Jupiter, Saturn, Uranus, and Neptune, were going to align in a super rare geometric arrangement. We're talking a once-in-175 years kind of event. Okay, let's dive into this, because this alignment allowed for an absolutely crucial piece of physics that made the entire mission possible: the gravity assist. By carefully aiming a spacecraft, scientists could use the sheer mass and gravitational pull of one planet to basically slingshot the probe toward the next. It's like cosmic pinball. This maneuver drastically changes the spacecraft's speed and trajectory, saving massive amounts of time and, more importantly, relatively scarce fuel.
Section 2. Slingshot through the planets. So, armed with the math of the gravity assist, NASA launched the probes into the dark, slingshotting them through the Jovian planets. But there was a massive engineering hurdle here. Once you get past Mars, the sun's rays just become way too weak. Traditional solar panels, practically useless. So to survive deep space, both of these twin probes were powered by RTGs, radioisotope thermal electric generators. Basically, they run on the heat released by the radioactive decay of plutonium. Now, comparing their paths is pretty interesting. Voyager 2 actually launched first, on August 20th, 1977. Voyager 1 launched 16 days later, but it was placed on a much shorter, faster trajectory. While Voyager 2 was tasked with an ambitious grand tour of Jupiter, Saturn, Uranus, and Neptune, Voyager 1 was on an express route, specifically targeting Jupiter, Saturn, and a very close flyby of Saturn's mysterious moon Titan.
And the planetary discoveries they made before even leaving our solar system? Absolutely mind-blowing. I mean, they discovered that Jupiter actually has rings. They found active volcanoes on Jupiter's moon, Io, which was the first time humanity had ever seen active volcanoes on another world. Voyager 2 became the first and only spacecraft to photograph Uranus and Neptune up close. And notably, Voyager 1 found clear evidence of liquid water on Titan, making it a prime candidate in the search for extraterrestrial life. Oh, and they also drastically increased the number of known moons around these gas giants. Just incredible stuff.
Section 3. Entering the interstellar void.
As spectacular as those flybys were, you have to remember, the true goal was always beyond all that. Voyager 1 actually used Saturn's gravity to intentionally shoot up and leave the ecliptic plane, that imaginary flat disk where all our planets orbit, and head straight out into the dark. To truly leave the solar system, the probes had to break through something called the heliosphere. Think of this as a massive, invisible protective bubble. It's formed by charged particles constantly blowing out from our sun, known as the solar wind. This bubble is vital because it shields our entire solar system from harsh interstellar radiation. Leaving home meant piercing the very edge of this bubble, a boundary known as the heliopause.
Just think about the sheer duration of this quest, launched in 1977. Then, in 1990, Voyager 1 turned around to take that famous pale blue dot photo from 6 billion kilometers away. But it took an agonizing 22 more years from that point to finally cross the heliopause. In August 2012, Voyager 1 officially entered interstellar space. Scientists confirmed this historic milestone by using the probe's plasma wave instruments. They detected a massive, sudden spike in electron density, proving it had finally left the solar wind and entered interstellar winds. And this brilliantly illustrates the sheer, staggering scale of what we're talking about, which is honestly kind of hard to fathom. As of late 2024, Voyager 1 is a mind-bending 24.7 billion kilometers away from Earth. It holds the undeniable title of the farthest man-made object in existence, racing through the cosmos at over 60,000 kilometers per hour.
Section 4. Humanity's Golden Record. Voyager isn't just some hunk of metal, right? It carries humanity's ultimate boon, a 12-inch, gold-plated copper phonograph record. It's quite literally our cosmic greeting card to the universe. The contents of this record were meticulously curated into 4 beautiful sections to explain who we are. It contains 115 encoded images and diagrams of Earth and our biology. It features spoken greetings in 55 different languages. It holds 28 tracks of global music, ranging from Western classical to an incredible Indian track based on Rag Bhairavi, sung by Sir Sri Kesarbai Kirkar. Finally, it includes 21 audio recordings of natural Earth sounds. It is an idealized, conflict-free portrait of humanity's spiritual and cultural insight, deliberately omitting war or destruction.
Section 5. Decoding the alien instructions.
Of course, sending a 1970s audio format into deep space presents an incredibly ironic challenge. NASA engineers actually included visual instructions etched right onto the cover of the record. They show how to place the disc on the box, how to set the needle on the grooves, the precise binary math needed to spin it at the correct speed, and most bizarrely, how to convert the complex audio waveforms back into the 115 images. I say this warmly, but let's be honest here, most humans today wouldn't be able to decipher these highly complex diagrams. Expecting an alien species, who might not even share our concept of visual geometry, to figure this all out is a monumental leap of faith. To understand why they had to do it this way, think about the computer storage, 69 kilobytes. That was the maximum storage available on the Voyager probes. That is a tiny fraction of a single megabyte. You can't even store one modern smartphone photo in that space, let alone 115 of them. So, NASA engineers had to invent a genius workaround. They projected the photos onto a screen, recorded them with a television camera, and converted those video signals into audio waveforms that could be pressed into the physical grooves of the vinyl. Pure brilliance.
Now, what's really interesting about this slide is exactly what the aliens will see if they actually manage to decode those audio waves back into images. They'll see a breakdown exactly like this, showing that Earth's atmosphere is composed of 78% nitrogen. They'll see the structure of our DNA, how our cells divide, and the chemical formulas for hydrogen, carbon, and oxygen, the fundamental building blocks of life as we know it.
Section 6. A fading human legacy.
We're reaching the bittersweet conclusion of this explainer. While the Voyager probes have pushed the boundaries of human engineering way beyond anything we could have imagined back in 1977, drifting at over 60,000 kilometers per hour, their active legacy is fading. Their journey into the deep unknown is becoming a silent one. The radioactive power supplies, those RTGs we talked about earlier, are dying. Scientists estimate that by around 2025, their power will deplete completely. Our communication with them will sever forever. The cameras have been off for decades, but soon the telemetry is going to stop too. However, even as the probes go dark and cold, the physical golden records attached to them will float silently in the vacuum of space, surviving indefinitely.
Which leaves us with this final, really profound thought to take away. Billions of years from now, when our solar system is vastly different, these records are still going to be out there. But even if an extraterrestrial intelligence does intercept Voyager, and even if they somehow manage to play the record, will they truly understand who we were? Or will they simply listen to the beautiful, mysterious noise of a lost world? It's a haunting and beautiful mystery, and it makes the Voyager missions our greatest cosmic legacy. Thank you for joining me on this explainer, and keep looking up.